Hello, my name is Longze Deng. My student number is S1497568. The hardbox challenge I chose today is Laugh Talk, and I will show you how to complete this challenge. My presentation is divided into 4 parts. The first part is a summary of the tag and the requirements. The challenge I have chosen this time is Love Talk. Love Talk is a dating website, and I will perform a penetration test on it. I will attempt to interact with the website and analyze its response based on my actions and the website's PHP code to identify any vulnerabilities that may exist. In this attack, I will explore its remote code execution vulnerability by modifying the URL input to execute system commands and access the website files and ultimately obtain the flag. This may result in sensitive data from the website's server being leaked. Requirements: implementation of runtime application self-protection solution to prevent remote code execution attacks. The second part is how attack is performed. First, open the laptop web page. When I click on that, that doesn't work for me. Try again. You can see that the URL has an additional parameter format attended to it. If you click on the button multiple times, you will notice that the time changes every time. It can be inferred that when a button is clicked, the web page sends a parameter format to the server, which is processed by the backend code and ultimately results in the change of time on the web page. Then I will open and analyze the time controller PHP in the controllers and open the time model PHP in the models. These files are all provided by the Hacker box. Then open the time controller PHP file provided by HTTP. It first checks for a get variable named format and assigns its value to the format variable. If there is no format parameter, the format variable defaults to R. Then, the method creates a new time model object and passes the value of the query parameter to it as a constructor parameter. Then open TimeModel PHP, and you will see that they use the add/is function to handle our URL input, which adds a \escape character to the formatter parameter passed up to the TimeModel class constructor. However, I still have a way to bypass this add/is function. The method is to use $signs and curly braces to reference variables, which add/is function does not escape. And here we can see that the constructor retrieves the format parameter and stores it in the class property list format. In the getTime function, we select the if function is used, which can pass a string as PHP code and execute it. Therefore, by constructing a malicious string, I can inject arbitrary PHP code, thereby achieving a remote code execution vulnerability. So I will control the format parameter by changing the input of the URL, then injecting my malicious code into the list format property. However, the @/ function escapes our URL input. To bypass the @/ function, I need to use $signs and curly braces to reference variables because @/ does not escape variables. Let's make a simple attempt which can prove that my attack approach is correct. As we can see, we print out the information of PHP, indicating that PHP info variable was not escaped by the @ function, and the PHP info function was executed by the system. However, due to the @ function, we cannot use double quotes in our URL input. Therefore, I will use the system function to execute the command passed in the get1 parameter, and I will set the value of the 1 parameter as the comment that I want to execute. This way, the system function will execute my command. So I will set the value of the 1 parameter as ls and slash to try to print out the directory. Here we can see the location and the name of the flag file. Finally, I will set the value of the 1 parameter as cat and the flag urhol to display the flag on the web page. Then the task is completed. The third part is the vulnerability and the exploit it used to complete the text. The vulnerability is a remote code execution vulnerability that allows an attacker to inject arbitrary PHP code into the server. By injecting malicious code through the formatter parameter and by passing @/, an attack can execute arbitrary commands where system gets one and retrieve the flag. The fourth part is remedy strategies. 1. The avoid using dynamic code execution functions such as eval, system exit, and so on, as they allow an attacker to execute arbitrary code on the server. Second, sanitize all user inputs before passing them to any function or method to prevent command injection attacks. Third, do not rely solely on client-side input validation. Server-side validation is necessary to ensure the correctness and safety of user inputs. Fourth, use prepared statement or parameterized queries for database operations to prevent circle injection attacks. 5. Avoid disclosing sensitive information such as server version, operating system, and error messages in web pages, as it may provide valuable information to attackers. 6. Keep web application software and server software up to date with the latest security patches to avoid vulnerabilities. 7. Implement a web application firewall to help detect and prevent attacks on web applications. Finally, by implementing these remediation strategies, web application owners can significantly reduce the risk of attacks and improve the security of their web applications. That's all for my presentation. Thanks for watching.